Let us evaluate the integral of ln of square root of x dx. We're going to apply the method of integration by parts. As you remember, in this method, when you have the integral of u dv, we can break it down into uv minus the integral of v du. If you take the derivative of both sides, they are equal to each other. So what's the choice of u? What's the choice of dv? The choice of u, let us take ln of square root of x as our u, and let's dv be dx. So in that case, when you're taking the derivative of ln of square root of x, it is square root of x derivative divided by square root of x itself dx. Remember that from calculus, when you have ln of u and you're taking the derivative of ln of u, it is u prime divided by u. In the case that it is positive, you just leave it as u. Otherwise, you need to use absolute value. So this is what you learned from elementary calculus. And now v is equal to the integral of dx, or v is equal to x. So we have all the missing information. Let us just plug them into the integration by parts formula and see what do we get. This is equal to uv. U is equal to ln of square root of x. V is x itself minus the integral of v du. V is x, and du is the derivative of square root of x divided by square root of x. Let us simplify this guy first before we plug that in to integration by parts formula. So du can be written as the derivative of the square root of x is 1 divided by 2 times square root of x, and the denominator is just square root of x dx. So du is equal to 1 divided by 2x dx. Very well. So my du is 1 divided by 2x dx. Guys, take a look. I can cancel out x and x. Well, it made it much more easier to calculate this integral. This is equal to x times ln of square root of x minus the integral of a half dx, which is super easy to work with. So this is equal to x ln of square root of x minus a half times x plus constant of integration.